Good morning guys, and welcome to part 2 of the Breath of the Wild rune series. In the first one we created our Link character blueprint. He can take aim like this with his reticle, and we're going to set up this reticle to do all of our stuff related to our runes. So the first one that we're going to crack into is going to be the Cryonis rune. We'll get started on that in this one. This will probably be the most lengthy and difficult one of all of the runes. It's definitely got like the most blueprint mechanics and the most maths and stuff involved, but hopefully we get through it and it's not too bad, and we don't have too many bugs and mistakes and problems on the way. But let's just crack into it, I guess. So I've got this little Word document. Hang on, it's just on my other monitor. If I just drag this up here, and that looks retarded because that is still the size of my other monitor for some reason, the wrong resolution. Hopefully you can see that alright anyway. So what I like to do before I create any new complicated blueprints is I tend to write down just a list of things that we need to kind of check off or manage in a brief description of how I'm going to do it, just to keep myself organized and make sure that things are clear and I know where I'm going and how I need to arrange things. So just if I run through this really quick, this is everything that we're going to be covering in this Cryonis tutorial, or the next couple of videos related to the Cryonis tutorial, because I doubt I'm going to get through all this on one video. We need to create a pillar blueprint, which is going to have functionality for scaling up from the water, and it's also going to have the functionality for being a simulation to demonstrate to the player where the pillar will be if they activate the pillar at that reticle position. We'll need to create some water surfaces that'll allow the player to spawn the pillar on them. We'll need to create the functionality for creating the simulation pillar at the location of the reticle. We'll need to move that simulation pillar to the new position of the reticle while we're aiming, so that the pillar actually updates its location. We'll create the ability to create a pillar when we click, auto-destroying pillars after we've got too many, allow the player to destroy pillars by clicking on the pillars. Then we need to add the checks to see if the player can actually spawn a pillar. So when we've got the simulation going, it'll change between blue or red depending on whether or not the player can actually spawn a pillar there. And there's a bunch of conditions that we'll need to set up for that. This is one of the most difficult bits. This will take a while, especially the 4 collisions on water. That'll involve like line traces and things, but that's fine. We'll get to that. Allowing the pillar to be spawned on walls. In Breath of the Wild, you can spawn pillars on 90-degree angles coming out of waterfalls and things like that. So we'll need to set up that functionality. This is quite difficult as well. This involves more maths and rotating stuff, and it can be quite a head fuck because it just gets confusing and you're not sure why things are facing particular ways, and etc, etc. Hopefully we get through that without too many problems. It should be alright. And then finally, after we get all of that done, we'll just add in some simple feedback to tidy things up. So I've got some humming sounds for while you're aiming the reticle. I've got some freezing sounds that sound kind of cool, some ice breaking sounds, and etc, etc. So I'm just going to put that down here. Let's just crack into it. The first thing that we'll do is we'll create the pillar blueprint. And we'll get through as much as we can in this video, and then we'll finish it off in the next couple or whatever. So in your content browser, right click, add a folder, and just call this Cryonis. Crack into that, right click, add a new blueprint class of type actor, and we'll call this Cryonis Pillar BP. And go ahead and open that up. The first thing that we'll do is we'll add a static mesh, and we'll call this pillar. Maybe we'll call it pillar SM actually. Pillar SM for static mesh. And the static mesh that we want is a cube. We want this shape underscore cube, and the reason that we want that one and not one of the other ones is because this is actually anchored to the bottom like that, which is perfect because when we change the scale, it'll scale directly up from that pivot point and we won't need to update the location of it on the fly. So I was playing around with this before, and the scale that we want is 1.6 on the Z. That's the right proportions relative to the rest. If you set it to 2, it kind of looks a bit too tall and it looks a bit awkward, so go 1.6. But this is actually too small as it is, so if we lock that now and then change the X to 2, So the final scale that we've got is 2.2 and 3.2, and that turns out to look about right. So I can show you what I mean. If we drop that in there and then hit play, that is a nice looking pillar. It's about twice our size. So that's going to be the size of our pillar. So now let's add in some functionality for actually scaling that up from the ground. So if you delete all the stuff in the event graph, just add a custom event, and we'll call this scale up from water, like that. And the way that we're going to scale it is we're going to use a timeline, and we're just going to call this scale timeline. Open that up, change the length to 1. I like to have all my timelines of length 1, and I'll explain why in a second. Add a float track, call this 0 to 1, and what we're going to do is we're going to add a keyframe at time 0 of value 0, and we're going to right click and add another keyframe at time 1 and a value 1. So 0 to 1, just like that, over 1 second. And just before we close this down, right click the keyframe and change the interpolation to auto, like that, and then add another keyframe right in the center, something like that, and change that interpolation to auto as well. And then if you drag this handle, you can get a nice smooth kind of curve thing going on like that. What if I change this one up here as well? No, that looks fine. Okay, so that'll just make the scaling look a lot nicer instead of it just being linear. So if we close that down, what we're going to do with this 0 to 1 is that's actually going to be a lerp. And that's going to be the alpha. So what this will do is as this cycles from 0 to 1, this lerp node is going to return a value from A, which will be at 0, and B, which will be at 1. So what we're going to use that for is we're going to say set scale, set world scale of our pillar SM. And we don't actually want that to be a float lerp, we want that to be a vector lerp, my bad. So we'll drag off of the vector pin, and we'll go lerp vector, and the alpha is going to be our 0 to 1 from the timeline. The initial value, we'll just want our X and our Y. Let me think about this, hang on, what if we say make vector out here? No, hang on, let's not worry about that. So X and Y are going to be 2 and 2 for A and 2 and 2 for B, and what we're going to be changing is we're going to be changing our Z value. The final value for our Z value is going to be 3.2, and the initial value will set to 0.01. I was playing around with this earlier, and I had this set to 0, and the problem is when it's set to 0, sometimes it flips the material on the outside inside out for some strange reason. So we want that to start at 0.01, and it'll look like it's basically non-existent, and from there we're going to scale up to 3.2. So let's just leave that as it is for now. One thing that we might do to test it is we'll go begin play. Oops. And on begin play, we're going to have a short delay, and then we're going to say scale up from water. Just like that. Compile and save. Control Alt S to save everything, and if we just drop in, there we go, that just scaled up just like that. Beautiful. Let's just change that delay to a bit longer actually, something like 2 seconds, just so we can really see how this looks. Hit simulate. Yeah, that looks really nice. Okay, if we want it to be a bit slower, you can drag in the scale timeline from your components tab, and you can say set play rate, like that. Hook that up in between there before the timeline actually plays, and then promote the rate to a variable and call this scale rate. And we could make this pillar spawn a little bit slower, so if we change that to say 0.5, this timeline will now run at half speed, so it'll take 2 seconds to scale up instead of 1 second. So if we hit simulate, we're waiting 2 seconds, and then there we go, scales up like that. That's probably a bit too slow, so I'm going to have that set to like 0.8 or something like that. Beautiful. Okay, so that's that setup. We might just quickly add some materials to this, and we might also create the simulation as well. So let's add another custom event, and let's just call this set pillar to simulation mode. And we'll use this later, we won't use this just yet, but let's just set it up. Basically, why we want this is because we're going to be using the same pillar blueprint as the actual pillar that spawns, and you can jump on and move stuff with it. But we're also going to use this same blueprint to create a simulation while we're aiming the reticle to visualize to the player where their pillar is going to spawn. So the only difference in the simulation one is we're going to grab our pillar static mesh and we're just going to remove the collision. So we'll say set collision enabled, like that, and we're just going to set it to no collision, just like that. And the only other thing that we'll also do is we might set the material of it to transparent as well, but we might not do that in this blueprint. We might do that in the player's blueprint. So let's just create some materials for it, because right now it's just this white ugly thing. So if we add a new material, we'll just call this Cryonis underscore M, I guess. Cryonis underscore M. These materials aren't going to be complex, by the way. They're going to be pretty ugly. So we'll left click, hold 3 and left click for a 3 vector, just like that. Hold M and left click for a multiply, hook the vector up to a multiply, and then hook that up to base color, I guess. And then we might just hold 1 and left click for a constant, hook that up to specular, 1 and left click for another constant, and maybe hook that up to the roughness like that. Set the specular to, like, I don't know, 0.6. I'm just freestyling here. I've got no idea what I'm doing. And maybe the roughness to 0.2. And then change the material up here, the color of the material, to some pretty blue. And let's see how that looks. Basically, the specular just makes it kind of shiny. The roughness makes it, the low value on the roughness makes it looking smooth. And the base color, we'll just set that to some kind of blue. And it should look, yeah, that looks alright. I mean, it's pretty ugly, but whatever. What do you expect? I'm not too good with materials. I might just lower that specular a little bit, and maybe I'll make this a little bit brighter. Don't worry too much about this, guys. My computer's freaking out right now. It doesn't like dealing with materials. Not while I'm recording, anyway. What are we at? 12 minutes. Alright. We'll wrap this up in a sec. I might just make that just a little bit wider. Just give that a sec while it saves. I'm going to take a drink because my throat's getting sore. I think I'm getting sick. Yeah, that looks alright. Okay, so let's close that down. What was I going to do? Okay, so if you go into your viewport and change your material of your pillar to just Cryonis like that, that looks alright. We'll also create some simulation materials really quick as well. So create a new material and then call this Cryonis sim, or Cryonis simulation underscore M. And this one is basically going to be a transparent one. So if you go down here into your material tab, change the blend mode to translucent, I think. Yeah, that's the one we want. Hold 3 and left click for a 3 vector. Hook that up to, hold M and left click for a multiply. Hook that up into the multiply and hook that up into emissive color. Let's change, right click your 3 vector and convert that to a parameter and just call that color. Set that to blue for now and maybe change your multiply to something like 3. Just to make that blue really pop. And then into the opacity, hold 1 and left click for a constant, hook that up into opacity and maybe change that to something like 0.75, and we'll see how that looks. So we should get a slightly glowing blue translucent material, which will make it look like a simulation. If you're good with materials, you could actually do like a hologram kind of thing, which would be awesome. I know that Dean Ashford, he's another tutorial YouTube guy who does really good material tutorials. He has a really good hologram material tutorial on his channel, which should be good for this. So go and check that out if that's something that you're interested in. But that looks pretty good for a hologram right now. So let's just close that down. Any moment. If you ever get sick of people stuffing around on YouTube doing their videos, you can always tap the right key on your keyboard and it skips through the video, which is a nice little way to save yourself time. So if you right click on this now, create a new material instance. We're going to call this Cryonis Simulation Blue, and then duplicate that, and we're going to call this one Cryonis Simulation Red. And these two materials are going to be blue for the valid positions and red for the invalid positions, which we'll get to later on. So I'm just going to click on that and then change that to a red, like that. Cool. So I might actually leave this one here. And in the next one we'll continue on. I'll just show you my Word document again. So what we've got now is we've got our Ice Pillar BP. We're scaling up from begin play. We've created our transparent materials, and we've got the red and blue. Yeah, so that's all good. So we can go ahead and we can cross that off just like that. And in the next one we'll do the water surface. Maybe we'll look into actually moving the simulation pillar around, spawning the simulation pillar, and spawning the actual pillar on click. So we'll do that in the next one. Let me know if you have any questions about this, guys. This is going to be a long series, so make sure that everything makes sense as we go. If anything doesn't make sense, or something doesn't work for you or whatever, and you can't figure it out, let me know and we'll troubleshoot it, because it's important that everyone stays with me as we go through it. So thanks for watching, guys. I guess I'll leave that there and I'll see you in the next one. Peace.